Okay, let's take a look at today's lesson. It is on vectors. It's our day 2 lesson. We're really going to be doing a lot of calculator work today, so hopefully you have your calculator with you. We're going to work through this entire problem, looking at calculator techniques and how to conserve our time. Alright, so we have a particle moving along a curve in an xy plane. We have a position, so we're in vector form at time t with, and we have our dx dt and dy dt equations. At time t equals 2, the object is at the position 7, 4. So that gives us a position information. We know that when t is 2, our x value is 7 and our y value is 4. So that's the bulk of the information that we have on the problem. So let's take a look at what they're wanting. Part A says write the equation of the tangent line to the curve at the point where t equals 2. Okay, so let's think about that for a second. If we want a tangent line, we need slope. In order to get slope, we need dy dx. Right, we need dy dx. We don't have that in that form, but we can easily get it. So we're going to have to treat it like a parametric at this stage because we need dy dx. The vector form of our velocity does not give us dy dx. So we need to actually kind of write that out. So dy dx, if you recall from the formula, is dy dt over dx dt. Okay, and we have those formulas here. So dy dt is cosine of t squared, and dx dt is sine of t cubed. Okay, so using the calculator, we still have to show some work. We can't just write like answers down. We need to show dy dx. What's dy dx? And we're actually looking for dy dx at 2. So we need dy dx at 2. And we can just write the number down once we get it out of our calculator. Okay, so let's go to our calculator. And we're using this formula in part A. We're asked for speed. That's going to use these again. Right, we're asked for a tangent, another tangent line problem. We're going to use these formulas over and over again. And it's to our advantage to put it in our calculator one time versus 3 or 4 because it's being used over and over again. So what we should do is we should go to our calculator, and I'm actually going to have to erase the writing. I hope that's all right with everybody. So we should go to our y equals, and we should put in those two functions. So if you go ahead and put those in, I put the sign. So I put dx dt first. You might want to make a note on your paper of which one you're putting where, because we're going to be using y1 and y2 in all of these other problems. And if you forget which is which, it could get a little confusing. So I put dx dt in y1, which is sine x cubed, and I put dy dt in y2, which is cosine x squared. Okay, so we get those in our graphing part. Okay, so we're using trig functions. It's going to be significant whether we're in the proper mode. We really always need to be in radian mode unless it specifies otherwise. So just check, make sure that you are in radian mode, and I am, so we're good to go. Okay, so we'll go out of there. All right, so it wants our tangent line. Okay. So we need our slope there. We need dy dx at 2. So what I would do, let's just go ahead and clear everything. Okay, so I would use a fraction. The fraction, if you recall, is alpha y equals, enter. Okay, so I have a fraction. I need to do the cosine one on the top, which I put in as y2. So I'm going to pull y2. So I go alpha trace, if you recall, that's where our y's are. So I'm going to do y2 is what I put there. So we're going to do y2. I want y2 at 2. And then I'm going to go to my denominator, which should be our sine function, and that I have in y1. So I'm going to do alpha trace, go over here, I need my y1, and I want y1 at 2. And then I just hit enter. And that's my slope. Okay, that's my slope. So now I can write my tangent line. So let's go back to the document to write our tangent line. So our tangent line is going to be y minus 4, again because we have our x and y components right there, equals negative 0.661 times x minus 7. And so that is the equation of our tangent line. So it's pretty important, as you were seeing, all this transpire, we really need to write down the things that we do. So we write down the equation, and then we write down the answer to the equation. I mean, that's pretty much with calculator work, that's what you need. You need to set up the equation and write it, then you need to put the answer. It doesn't involve a whole lot of writing, but you have to write stuff. Okay? And so that is part A. That's our tangent line. Are we okay with that? All right, let's look at part B. It wants us to find the speed of the particle at t equals 2. All right. So I don't want to, I have to show the formula for speed. You have to show the formula for speed. Or you can't just write the answer. So we're going to show the formula for speed. We know the formula for speed is the square root of the dx dt squared plus dy dt squared. So I'm going to write dx dt at 2 squared plus dy dt at 2 squared. That's really communicating exactly what I'm doing. I don't have to copy this formula down and put a 2 in it. I can just say dx dt squared, dx dt of 2 squared and so forth. That's plenty of work. Then I'm going to just say equal, and I'm going to go to my calculator. I'm going to type all that stuff in. Okay, so let's go to our calculator and let's type all that in. Has everybody got this? We okay? Okay, because I need to erase that. All right, so let's go to our calculator. And we need to type in the square root of. We need dx dt. It doesn't matter the order I put it in, so we'll just do, dy dt is fine. So alpha y1 of 2. Okay, I need to square this, and I'm doing this on purpose actually. I forgot to put the parentheses in because I want to remind you of one of the most wonderful things that I discovered several years ago, the insert button. It's like, where have you been all my life, the insert button? So I go back, because I always had to type everything over when I made a mistake, because, I mean, who doesn't make mistakes, right? We all make mistakes. So here's the insert button right here. Second, delete. I can put my parenthesis. I don't have to retype everything. I'm happy. I close it, and we have to square it. Okay, plus, and then I need y2, so alpha, trace, we're going to go to y2. Okay, oops, I forgot the parentheses again. So I'm going to go back, and I'm going to do second, delete, where my insert button is, put my little parentheses back there. Okay, so I need y2 of 2. So of 2, and I need that squared. Okay, so there's our formula. So we hit enter. And we get, that is our speed at time equals 2, 1.1857. So we go back, and let's record our answer. So we had our formula written here, equals 1.1857. And you can round or truncate, or you can go to 4 places, whatever you like. Okay, are we okay on speed? Yes? You see, the amount of time that you're going to save by putting it one place, and your errors is going to be significant. So let's keep going. So let's look at part C. Part C says, for what value of t between 0 and 1 does the tangent line to the curve have a slope of 4? Find the acceleration vector at this time. Okay, we got a couple things going on. First of all, we need to know what value does the tangent line to the curve have a slope of 4? All right, so the way I do it on my calculator is I go to my grapher and I intersect those two things. There's other ways to do that on your calculator. You can do that however you want, but I'm going to go to my y equals, and I'm going to turn off y1 and 2. I'm going to move my cursor over to hover over the equal sign and hit enter. What that's going to do for me is it's going to make sure that it doesn't graph those two. I don't want to see those two. Okay, I don't want to see those graphed. So I do need them there, but I just don't want to see them graphed. So I would say 4. So I put the left side in, one side and the y side in the other. So 4, and then we want to know when the slope is 4. So I need to set up the slope. So I put a fraction. So our fraction would be, again, alpha y equals, there's our little fraction guy. And it's the dy dt over dx dt. So the dy dt I put in as y2. So let's pull that down. So y2 is, so we do alpha, trace, and I need my y2 over, and we need our dx dt, which I put in as y1. So alpha, trace, y1. Now, it would probably be to our advantage to mess with the window before we jump in and graph, because who knows what this graph is going to look like. I really only care about between 0 and 1. I mean, that's all I really care about. So I'm just going to go to my window and I'm going to change, my x min to 0 and my max to, and if you feel a little uncomfortable about that, why don't we do -1? So -1, and then we'll do 2. I mean, just to kind of narrow it down. We only care about between 0 and 1, but let's just give it a little bit more space. And so let's graph and see what happens. Okay, so this is the area right here. This is the only one between 0 and 1. That's the one that we are interested in. So let's go ahead and find that intersection. We know that is second trace. That goes into our calc section. Intersect is number 5. You may or may not know this, most of you probably do, that I can move that little cursor between functions by pressing the up and down arrow. If I press the up arrow, you can see that I'm on, the y2 over y1. If I press the down arrow, you can see that I'm on the line. And certainly it would be quicker to get there on the line, right, than it would be to just travel all around the other little things. So we're going to go to our intersection, hit enter, enter, and enter. Okay, so that's our intersection. We need that x value. We're going to use that x value, so we need to store it. So what we do, the calculator has it right now stored in x. That's where it is right now. That's why you never store in x, ever. Because every time your calculator finds another x, it replaces whatever you put in there. So you always store in like A, B, C, somewhere else. All right, so let's go and go to our clear screen. And I'm going to type x and enter. And you'll see that it's that value that the calculator just found for us. And so we're going to store that because we're going to need to use it again. So we store that, we press store, and then I usually store it in alpha A. You can store it wherever you want. I just don't store it in X or Y. It's just not a good idea. So it's stored. Okay, so we're good. So let's see what part 2 wanted. We found the tangent line, so we need to, for our work, we need to say 4 equals, and we're supposed to set it equal to our dy dx, so 4 equals cosine t squared over sine t cubed. Okay, so that's the work that we show, and then we write t equals, and then we write that answer that we got, which was 0.61648. Okay, that finishes out the work for that first part of the question. The second part of the question says, find the acceleration vector at this time. Okay, so we need acceleration vector. We could do this by hand. We actually need to show the acceleration vector. So we could take the derivative by hand, but we have a calculator. Why don't we make the calculator do it? That would seem to be easier. All right, let's make the calculator take the derivative. So let's go, going to need to erase. Let's go to back to our calculator. And we need acceleration vector. So we want the derivative, which is math 8. So math 8. And we want, with respect to x, doesn't really matter which one we do first. Let's go ahead and do the dx dt first, which we put in y1. So alpha calc, here we go, is our y1. And then I want that at the value that we calculated at a, because I stored it at a. And so we hit alpha a. So this is going to give us our x component. So this is the x component of our acceleration vector. Okay, let's go back and let's find the y component of our acceleration vector. So again, math 8. This time it's with respect to x. We're going to pull down that y2, so which was alpha trace, and let's move to y2. And we want that at that value that we calculated previously, which we have in alpha a. And so there's our acceleration vector. Okay, so let's go back and see what are we going to show in our work. So we could say the acceleration vector at, what was it, 0.616 is, and then we have 1.109 and negative 0.457. And there's our acceleration vector at that time. Okay, we okay? All right, last part. Find the position of the particle at time t equals 1. Okay, so position, we have, velocity, we have our derivative, we need to integrate. Now I'm going to do this integration a little bit different than yesterday. We're going to do a definite integral instead of an indefinite integral. All right, so we're going to do our x of t is going to equal the integral from 1 to 2. Okay, why do I choose 1 and 2? I choose 1 because that's what I want, and I choose 2 because that's what I have. That's why I choose that. One of them that I want, one of them that I have. Hopefully this is kind of ringing a bell. We've done this before. And then we need to put, so sine of t cubed dt equals x of 2 minus x of 1. Okay, so what do? I put this in my calculator. So let's move to the calculator real quick and kind of get that down. So we need our integral, which is math 9 from 1 to 2. And we want to put the sign there, which we put in y1. So alpha trace y1. And then our dx. Okay, so we have that value, 0.21810. Okay, so we have 0.21810 equals x of 2 we know is 7 minus x of 1. So our x of 1 ends up being 6.7818. Okay, we okay with that? So we just solve for the x of 1, move the 7 over, multiply by negative 1, do all that algebra. And we get 6.7818. All right, so now let's find our y component, y of t, integral 1 to 2 of cosine of t squared dt. equals y of 2 minus y of 1. Okay, so let's go back. And you probably already know this, but I'm just going to talk about it anyway. If I don't want to type that all over again, I just need to go up and highlight it and hit enter. That pulls that down, and then I can just scroll over and change the y1 to y2. Okay, so we're going to change that to y2. So that would be, where are we? Alpha trace. Our y2 is right there. Enter. And so that's what you want to do. Enter again. And that's our value. So now we're going to, so negative 0.44306. All right, let's go back. So we have negative 0.44306 equals, our y of 2 is 4 minus y of 1. We solve for y of 1, and we get y of 1 equals 4.443. So our position is going to be, and you need to write it in either vector or point form, 6.782 and 4.443. All right, how is that? We okay?